Hello students, we are now going to solve an IVP where the right hand side is a unit step function. So this type of problem lends itself to the Laplace transform because of the properties of the Laplace transform. So we're going to, as we've done before, we're going to apply the Laplace transform to both sides. And if we do that, we get s squared times big Y of s minus 1 minus 5s times y of s plus 6 times y of s equals, now on the right hand side you have to recall what happens when you take the Laplace transform of the unit step function, okay? So on the right hand side, think of it as just being 1 times h of t minus 1. And remember that the Laplace transform of 1 is 1 over s. So we're going to have 1 over s times e to the negative s. So the right hand side again is e to the negative s divided by s. So collecting the terms involving big Y of s, we have big Y of s times the quantity s squared minus 5s plus 6 equals 1 plus e to the negative s over s. So we're going to now divide both sides by y of s. Remember, the final step is to invert. We have y of s equals 1 over s squared minus 5s plus 6. But you may notice that that trinomial can actually be factored. That is s minus 2 times s minus 3. And we'll have plus e to the negative s times 1 over s times s minus 2 times s minus 3. We are almost done with the problem. We just have to invert. So we'll do this first term first. And the work that we do, it turns out that we're going to get to use that in the second term. So what's going on right now is this. Our final answer is going to be the inverse Laplace transform of 1 over s minus 2 times s minus 3 plus the inverse Laplace transform of e to the negative s times 1 over s times s minus 2 times s minus 3. So, for this first term, of course, we're going to use partial fraction decomposition. 1 over s minus 2 times s minus 3. It's a very simple situation. We end up with 1 over s minus 3 minus 1 over s minus 2. Now, of course, when you invert this, the inverse Laplace transform of 1 over s minus 3 minus 1 over s minus 2. This ends up being e to the 3t minus e to the 2t and then to invert this second term, there are a couple of things going on. Notice that we're dividing by s, which means we're going to integrate. And also we have e to the negative s, which means we're going to be using this property. Okay, so multiplying by e to the negative s, this a is equal to 1 means that the inverse is going to involve the step function. Okay, so the inverse Laplace transform of 1 over s times s minus 2 times s minus 3, what happens is we start with our previous answer from the previous term. In place of t, put u. Let's say then we integrate with respect to u from 0 to t. So this part ends up being equal to (1/6) plus 1/3 e to the 3t minus 1/2 e to the 2t, but then making use of the property involving the step function. What happens is we're going to take this result, replace t with t minus 1, and then multiply all of this by the unit step function. So we get h of t minus 1 times 1/6 plus 1/3 e to the 3 times t minus 1 minus 1/2 e to the 2 times t minus 1. So combining everything, y of t is going to be equal to e to the 3t minus e to the 2t plus h of t minus 1 times 1/6 plus 1/3 e to the 3 times t minus 1 minus 1/2 times e to the 2 times t minus 1.